One-step equations were simpler because there was only one thing we had to do to get the answer. For two-step or general equations, we have to decide what we need to do first. There are problems with some choices, and other choices aren't helpful. So it's very important to make the right choice. We want to get rid of any term adding or subtracting with the variable term. Then we want to get the coefficient away from the variable, typically by multiplying or dividing. A lot of this stuff is easier to see in practice. We're going to do just that. For this first problem here, 9x minus 5 equals 13, the first thing we want to do is we want to get the coefficient and variable term by itself, the 9x. To do that, we're going to get rid of the other term, the negative 5. In this case, we're going to add 5, because adding 5 will cancel, giving us 9x equals 13 plus 5 is 18. Now this is just a one-step equation. 9 is multiplying x. How do we get rid of a multiplication? We do division. We divide by 9. 18 divided by 9 is 2. You can always check your work. 9 times 2 minus 5 equals 13. And just use PEMDAS. 9 times 2 is first. That gives you 18 minus 5. And 18 minus 5 is 13. That's a true statement. Therefore, we know x equal to 2 is the correct answer. Okay, for this next one, very similar. 3x plus 12 equals 24. The first thing we want to do is get the 3x by itself. We're going to do that by getting rid of the plus 12. So I'm going to subtract 12. You always do the opposite or inverse operation to get rid of something from one side of the equation. Those cancel, and we have just 3x. 24 minus 12 is 12. Now we have a one-step equation. 3x equals 12. 3 is multiplying x. We get rid of the 3 by dividing by 3. 12 divided by 3 is 4. Once again, you can check your work. 3 times 4 plus 12 equals 24. 3 times 4 is 12. 12 plus 12 is 24. When you're checking your work, all you have to do is PEMDAS. That's all I'm doing there. All right. The next one, x over 2 plus 6 equals 16. Again, we want the variable term by itself, so I'm going to subtract 6 to both sides of the equation. You can draw the equation bar. It's kind of better if you don't, if you get in the habit of seeing that, but of course you can. It's just going to make it more work for you to do, but that's fine. X over 2, 16 minus 6 is 10. Now here, 2 is dividing x, so to get rid of the division, we're going to multiply by 2. That cancels with that 2, and we get x equal to, well, 10 times 2 is 20. Checking our work, we have 20 over 2 plus 6 equals 16. Of course, I'm just plugging the 20 into the x slot. Clear off some of that stuff to see where it's going. 20 over 2 is first. That gives you 10 plus 6 equals 16. And 10 plus 6 is 16, which is a true statement. 5x over 7 equals 8. I'm going to first get rid of the division by multiplying. I like to work left to right. Typically it saves me more space, so I'm going to do that. But you can work top down. That's fine too. But you'll see that this cancels and we get 5x equals 8 times 7 is 56. And then all we have to do is divide by 5 to get rid of the 5. That gives us x equal to 56 over 5. There's no need to simplify that. That's fine there. We don't need to get mixed numbers or anything like that. This one I want to check really quick to make sure we have it all good. This is a 56 over 5 plugged in, that's what the equation becomes. 5 times 56 over 5, the 5's cancel because the 5 is multiplying here and it's dividing there. That gives me 56 over 7 equals 8. And 56 divided by 7 is 8. So that's a true statement. Okay, for this one, here we're going to add 10 minus 8x equals negative 3 plus 10 is going to be a positive 7. And now we have to divide by negative 8 because the negative 8 is multiplying x. So now we get x equal to negative 7/8. Positive divided by negative is negative. That's the reason why I put the negative out in the front. And 7 divided by 8, well, that's just 7/8. So there's no reason to simplify that at all. Negative 7/8 minus 10 equals negative 3. Checking our work here. Negative 8 cancels with that negative and that 8 there. Two negatives will always cancel. That's the reason why I cancel them like that. And the 8's cancel, giving us 7 minus 10 equals negative 3. And 7 minus 10 is negative 3. Okay, so that's two-step equations. There was always two things we did. In a lot of these, it was first adding or subtracting the term, and then multiplying or dividing. This one right here was a little bit different. Let me use a different red color here. That's because we had 5 multiplying the x and 7 dividing the x. And so this one actually doesn't matter which order you go in. You could multiply by 7 first or divide by 5 first. Either way is fine. That's because multiplication and division are inverses of each other. So you can do either one first. However, in all of the rest of them, the first step I did was always get rid of that extra term adding or subtracting onto the variable term. That's always a good first step when you're solving two-step equations. Okay, so that's two-step equations. Now we go on to general equations. And typically, what you want to do is get the variables to one side first. If you do that, you're pretty much good to go because the equation should probably collapse down into a two-step equation, which we've already talked about. So in this case, I'm going to move the variable to one side. It doesn't matter which side you move it to. In this case, right, 8x is positive and 5x is positive. I could subtract 8x here and move it to the right-hand side. Doing that gives me negative 2 equals 4 plus, or no, not 4 plus, 5 minus 8 is negative 3x. And now this is a two-step equation. So I first need to get rid of that 4. To get rid of the 4, I'm going to subtract 4. That's because 4 is positive here. That gives me negative 6 equal to negative 3x. And now I divide by negative 3, which gives me x equal to negative divided by negative is positive, and 6 over 3 is 2. So x equals 2 here. I could have also moved the 5x to the other side by subtracting 5x this way. Those cancel, and we get 3x minus 2 equals 4. So you see how in the other problem, I have the variable on the right-hand side. In this problem, I have the variable on the left-hand side. It doesn't matter. You're going to get the same answer both ways. Just make sure you do it one way. But either way that I did it, you see that I have a two-step equation after I do it. Now I can solve by doing the normal two-step equation process. So I'm going to add the 2. That's always the first thing you want to get rid of, is the term that has no variable. Get it over to the other side of the equation. Now we have 3x equals 4 plus 2 is 6. Divide by 3, and we get x equal to 2. Same answer, which is expected, but just a slightly different way of doing it. Okay, with that in mind, now we can start talking about just general equations. And for instance, in this problem here, let me get a little bit more room here. For this problem here, we have a set of parentheses. Typically, we do not want parentheses in our linear equation. That's because they tend to be harder to work with. You also can't combine like terms with them and all that kind of stuff. So the first step should always be distribute to get rid of the parentheses. In this case, I'm going to distribute the 2. That gives me 8 plus 2x, and then 2 times negative 7 is negative 14. And you should always combine like terms when possible. 8 and negative 14, they combine into a negative 6. You could have also written it like this, negative 6 plus 2x. These are the exact same equation. Whichever one makes more sense to you, just do that. Now all we have to do is solve, and this is a two-step equation. We're going to get rid of the non-variable term. 0 plus 6 is 6, and then divide by 2. We get x equal to 3. This, of course, is the exact same thing. We're not changing anything process here. It's just a different way of thinking about it, if you like. But the first thing I did was I distributed right here to get rid of parentheses, and then combine like terms. If you can combine like terms, you're going to be having a much easier time solving the equation. All right, for this problem, let's distribute. You get 6x, 2 times 3 is 6, 2 times 4 is 8. And now you see I have variables on either side of the equation. Let's move it to one side. You can do it however you want. I typically like to have my variables on the right-hand side, but I also like to have my variable terms positive. So for me, I would never subtract 6x to this side. That's because x minus 6x gives you negative 5x, and I don't like having a negative with my variable. It doesn't matter, you'll get the same thing either way. That's just my personal preference. So I'm tending to do this. That way, I have 5x plus 8 equals 6. Just to kind of make sure we're on the same page, let me just show you the other way as well. Minus 6x on both sides. We get 8 equals negative 5x plus 6. For this blue way, I'm going to do it in blue here. I'm going to subtract 8. That gives me 5x equals 6 minus 8 is negative 2. So now I can divide by 5. And we get x equal to negative 1/2. For the green way, I have to now subtract 6 to both sides. That gives me 2 equals negative 5x. And then divide by negative 5. And that gives me x equal to positive 2 divided by negative 5. Positive divided by negative is negative. And 2 over 5 is just 2 over 5. So you see, again, both ways give me the same answer. It's just kind of, in my mind, the blue way is a little bit simpler because you don't have to deal with that extra negative. But it doesn't matter. You'll get the same answer both ways. Okay, this one, distribute first. Now we're distributing a negative 2. Make sure you always distribute a negative if it's in front of a number there. So we have negative 2 times x is negative 2x. Negative 2 times 3 is negative 6. And here we can combine like terms. The 6 and the negative 6 actually cancel. So now we have negative 2x equals 1 plus 4x. And so I can, what I would do is I would actually, in this case, I would actually subtract 4x. That's a little bit weird because I said I don't like negatives. But if we were to add 2x to the other side, there's more steps we have to do. I'll show you both ways. So for this side, I'm going to subtract 4x. I'll do it in blue here, and then I'll do it in green on the other side. So I'm going to subtract 4x, subtract 4x. That gives me negative 6x equals 1, and then divided by negative 6, which gives me x equal to negative 1/6. So that's what we're looking for in this second way. I'm going to add 2x on this side, just doing this as a different way. We have 4x plus 2x is 6x. Now we have to subtract 1. That's the two-step equation, right? That's the method that you do it. So 1 minus 1 is 0. We get negative 1 equals, because 0 minus 1 is negative 1, right? So negative 1 equals 6x. Now we can divide by 6. And we have x equal to negative 1/6. So both the ways are the same. The blue way is faster, but it requires keeping your head in the game to see what you can do to be faster. Both ways work though. So if the green way makes more sense to you, which is the typical way we've been doing it, just do it that way. All right, let's do this last problem before we move on to some application. This one's a bit longer. We have a lot more x's. The first thing I'm going to do still is distribute to get rid of parentheses. We have 7x plus 3x. Negative times 10 is negative 10x. Negative times 2 is negative 2. And we have 5 plus x. So we have a lot of like terms here. 7x, 3x, and 10x. 7x plus 3x is 10x. And 10x minus 10x cancel. That one was nice. If it didn't cancel, you just move the variables together on one side, just like we did in the previous problem. Right? In this problem, I subtracted 4x to this side so that I could get the variables together. In this one, I added 2x to this side to get the variables together. In this case, we don't have to worry about it because there's only one variable here. So we're good to go to continue. Always get rid of the term that's not a variable term, right? We want to leave the variable term by itself. So I'm going to get rid of the 5 by subtracting it off. It's positive, so I need to do the negative. It gives me negative 2 minus 5 is negative 7. And here I don't have to divide by anything or multiply by anything because x is by itself. So x equal to negative 7 is our answer. For this problem, let's check it real quick. See what we get. Just plugging in x into all of the x terms. There's a lot of them, so equals 5x plus 2. Or 5 plus x, which is negative 7. I don't know why I said 2. Okay. So PIMDAS, always. So we're going to do the parentheses first. 7 times negative 7 plus 3 times negative 7 minus 10 times negative 7 is negative 70 plus 2. So we have negative 70 plus 2. This gives you negative 68. Now we're going to do multiplication and division. 7 times negative 7 is negative 49. 3 times negative 7 is negative 21. We have a negative and a negative right next to each other. And a negative and a positive right next to each other, so it's going to be a minus. This is also a negative and a positive, so I'm going to make it minus. And you see here, all we have left is addition and subtraction. Working left to right, we have negative 49 minus 21 is 70, negative 70 plus 68. Negative 7 plus 68 is negative 2. And 5 minus 7, we can also do 5 minus 7 is negative 2 as well. That's a true statement, so we've done it correctly. X equal to negative 7 is the answer. The formula P plus 2T equals C gives us the overall diameter C of the crankshaft gear for a known pitch diameter P. If of the small gear and the height T of teeth above the pitch diameter circle. A lot of language there, which doesn't really help us because I'm not really sure what it's talking about. However, it does give us what P and C are, and it asks us to find T. So if you're not sure what to do, well, write down the formula that's given and plug in the things that are given. P equals 2.875 and C equals 3.125. Now these parentheses don't actually mean anything. There's no multiplication or exponents or anything like that. So I can actually drop them. And now you see, well, this is a two-step equation. The first thing I'm going to get rid of is the number by itself. So I'm going to subtract that since it's positive right now. Now I have 2t by itself. So 3.125, let's see, 2.875, yeah, 0.25. And now we can divide by 2. That gives us t equal to 0.125. And does it say what t is? The height t, I mean inches since the rest of them are in inches. All right, we have a formula again. We have under certain conditions that approximate the length of belt needed to connect two pulleys with radii R and capital R. And their centers of the radii of the pulleys are going to be d distance apart. Just kind of give you a picture. I can actually draw this one. We have a bigger pulley. This is going to be our center here. The radii of this pulley is going to be 8 inches. Then we have a smaller pulley. This one is 6 inches. This distance here is d. And a belt is going to go across these. Make sure I can draw it here. All right, and the belt length is L. And so you can use this formula, and we're saying it satisfies the certain conditions that it's required. We can use this formula to figure out what we need to. It says that it's asking how far apart can two pulleys be if their radii are 8 inches and 6 inches, and the total length of the belt that connects them is 82 inches long. Well, we're asking how far apart the pulleys can be, and that is asking what is D in this situation. Again, we have a formula, so let's just plug the numbers in to this formula and see what we have. Plus R. L is 82. You don't know what D is, so we're going to leave it as D. Lowercase r is 6, and capital R is 8. And this, we can simplify this quite a bit. 8 plus 6 is 14. And 3.26 times 14 gives us 45. Let me get there. 45.64. This is a two-step equation. We can solve by first getting rid of the 45.64. It's positive, so I'm going to subtract it. 45. Okay. Now we have 2D equals 82 minus that. Gives us 36.36. And divide by 2. I'm guessing give us 1818. Yep. 18.18. And this is the distance that D can be, farthest distance here. And these are all in inches. You can see inch, inch, and inch. So we're going to have 18.18 inches possible. Probably should round it. Yeah, it says round to the nearest inch. The nearest inch is going to be here. So we look at the 1. It's not 5 or greater, so we just drop that stuff. And so D can equal 18 inches. All right, the total engine displacement D is given by quite a long formula. B is the bore, S is the stroke length, and N is the number of cylinders. What is the stroke of a 6-cylinder engine with bore 3.5? So it says what is the stroke length? It should be stroke length. So we're looking for S. That's what we're trying to find there. What is S when we have a bore of 3.5 inches and a total displacement, capital D, of 216? And of course, we're going to use pi estimated to 3.14, which is the pi symbol right there. So we have D equal to, actually D is 216 inches cubed. Pi is going to be 3.14. I can put that in parentheses as well because I plugged it in. B is going to be 3.50, and that's being squared. We don't know what S is, and we know that N is the number of cylinders, which is a 6-cylinder engine, so N should be 6. This is all over 4. Okay, let's simplify this. I can get rid of the parentheses around 216. They don't actually do anything here. And I can simplify a lot on the top. I first need to do 3.5 squared. Oops. And that gives me times 1225. I'm going to flip the S and the 6 around. And now I can just multiply 3.14 by 12.25 and 6. Doing that collapses the top into one thing, giving us 216 equals 230.79 S over 4. Now we can solve this. This is a two-step equation. I'm going to multiply by 4 first to get rid of the denominator. That gives me 216 times 4 is 864 equals 230.79 S. And finally, we can divide by 230.79 to get S by itself. 864 divided by 230.79 gives me 3.7436. It continues. This doesn't say any kind of rounding, but as you can see, most everything has 3 places, 3 significant digits. Also, it has, three significant figures. So I'm going to round to 3 significant figures here. 3 significant figures is going to be this place here. We look to this place. It's not 5 or greater, so we can just drop that. So we get 3.74, and this is the stroke length, which everything is in inches except for the displacement, which is in inches cubed, and this is going to be an inch. All right, here we have a student having a test average of 89.4 for the first 5 tests of the semester. What score should the student need on the 6th test in order to achieve an average of 90 for all 6 tests? This is a classic math problem for this level of mathematics because it requires you to think about, well, how do I find the average of 5 tests? How do I find the average of 6 tests, and that kind of idea? Well, the average of 6 tests, let's call the tests x1 for the first test, x2 for the second, x3 for the third, there's the fourth, there's the fifth, and this is the 6th. This is a classic way of writing in mathematics. We use a subscript to denote These are all tests. That's why they're all x, but they're not the same x. You can't just use x and x and x and x. No, you could use different variables like a, b, c, d, e, f, g, but it's actually more understandable to see that we have a test of the first variety. So the first test, the second test, the third test, fourth, fifth, sixth. So you're associating tests with x variables, but you're distinguishing them with a subscript, which is the 1, 2, 3, 4, 5, 6. To find the average of tests, you have to add them all up. And divide by how many there are. How many tests are there? Well, there's 1, 2, 3, 4, 5, 6 tests. And that gives you the average. Well, we want an average of 90, which means this thing must equal 90. The question is how do we find the variables? We have 6 variables here. We need to have some way of simplifying this so that we can actually find an answer to this. Well, let's look at the first piece of information. A student has a test average of 89.4 for the first 5 tests. Well, we know the first 5 tests. We have variables for them, which means if we do the average of this, this time it's going to be over 5 because there's 5 tests here. This equals 89.4. Now, you can see that x1 to x5 is here. x1 to x5 is here. If there's some way of getting the bottom equation to equal x1 to x1 plus x2 plus x3 plus x4 plus x5, if there's some way to get that by itself, then we can actually insert whatever we get on the other side of the equation into this equation with x6, because it's asking us what would the student need on the 6th test. What we're really trying to find is what is x6. If we know that, then we have our solution. Well, hopefully this makes sense. All I'm going to do here is multiply by 5. And that gives us 89.4 times 5 is 447. And now you see we have x1, x2, x3, x4, x5 all adding it, and it equals 447. What I can do mathematically then is replace 447 here right wherever this box is. And that box is right there. So I can replace x1 plus x2 plus x3 plus x4 plus x5 with 447. When I do that, what does that look like? It looks like this. Let me go down. Looks like 447 plus x6 over 6 equals 90. All I've done here is I've just replaced the box. This boxed in thing, which is this box, it's the same boxed in thing there, with what it equals to, 447. That's all I've done. So this whole equation simplifies down to this statement here. And this is a linear equation that we can solve. The first thing I'm going to do is I'm going to get rid of the division. That's because we can think of parentheses being here on top. The way we get rid of it isn't to distribute the division by 6. In this case, because there's a division, we're going to actually get rid of it by moving it to the other side first. I'm going to do that by multiplying by 6 to both sides. This is a different case than what we've done before. If you have a division like this, then the first thing you should do is multiply it to get rid of that division. When you do that, we get 9 times 6 is 540. we get this is actually a one-step equation. It's not two-step. So we can actually just subtract 447 to both sides. $540 minus 447 gives me 93. That means the sixth test needs to have a 93. If it does, then all of the averages will give a 90 at the end of the semester. This one's a little bit more involved because of this relationship here of seeing how the averages combine. But what's nice about this is that it shows you how it breaks down into a simpler equation rather than having 6 variables. We only have one variable here, x6. And once you have one variable, well, you can just use the techniques that we've talked about in this video to solve it, and you'll have your answer.